All right, we're going to continue with our identities after we've looked at the basic identities. Today we're going to be introducing the sum and difference identities, or the sum and difference formulas, and then we're just going to start practicing using them. So I'm going to be doing 2 videos for 7-5. All right, so let's take a look at how the sum and difference formulas work and what they are. First of all, we're going to take a look at sine. Now, because we're adding and subtracting, we're talking about 2 different angles. So I'm going to use alpha plus beta. And if you don't want to use alpha and beta, you can use a capital A and a capital B. So I will interchange both to make it easier. So the sum formula is the following. Sine alpha times cosine beta plus cosine alpha times sine beta. And then if we take a look at the difference formula, this means if we have 2 angles and we're subtracting them, alpha minus beta. Well, what's really nice about this is it's the same idea. Sine alpha cosine beta, but this time it's going to be minus. So one of the ways I personally remember it is sine stays the same. So the sine, if this is a plus, it stays the same as a plus. If it's a subtraction, it stays subtraction. And I'm just going to go ahead and give these to you. Cosine A plus B, or alpha plus beta. Okay. Now cosine alpha plus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. So it goes cosine cosine minus sine sine. Cosine alpha minus beta, therefore, is going to go cosine alpha times cosine beta plus sine alpha times sine beta. So you may notice some patterns. And then in order to find tangent, we know technically that tangent is sine divided by cosine. So I could literally take sine alpha plus beta divided by cosine alpha plus beta. And the proof then is to multiply by a conjugate, and you end up with the following. So I'm just going to give them to you this year. Tangent of alpha plus beta is tangent alpha plus tangent beta over 1 minus their product, tangent alpha times tangent beta. And then our last one that we're looking at is the difference, tangent alpha minus beta. It's going to be the same pattern, but the signs are switched. So since it's subtraction, it's tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. So what we're going to do first of all, we're going to use these. So this first video is going to be how to use the identities, and then our second day will be establishing the identities. So when you go to do your homework, have this master list. Have this list on a piece of paper right next to you. And here's how we use it, okay? Now, before we use this, we want to remember our special triangles. We want to remember the unit circle. because those are going to stay the same. We need to still use all those measurements. We do not have any others to worry about because if I have cosecant, I would just do 1 over sine. If I have secant, I would just use the reciprocal 1 over cosine. Same thing for cotangent. I would just take the reciprocal of these. So here we go. Let me show you how we can do this. Find the exact value of, and I'm going to put it in degrees first. All of the directions are going to be the same. Find the exact value of. Let's go sine of 75 degrees. Now without a calculator, we want to find the exact value of this. So we'll have radical in the problem, something like that. So our goal is to come up with numbers that we know that through either adding or subtracting, I can come up with 75 degrees. Always keeping in the back of your mind our special angles and the unit circle. So keep in the back of your mind, and I'm not writing very large, think about the numbers 30, 60, 90, because we know that triangle. Think about a 45, 45, 90, because we know those ratios. And think about the unit circle, because we know all of those ratios. And on the unit circle, sorry, this ran off, so I'll throw it over here. You know the unit circle, 0, pi over 2 or 90, pi, 3 pi over 2, and 2 pi. So always in your back of your mind, think about those numbers. So think about which two angles add up to 75 or which two angles subtract to produce 75. And you may say, oh, you know what? If I take 30 and 45, I'm going to get 75. So this is what we do. This is how nice this is. We say, okay, sine of 75 degrees is the same as 45 plus 30. Or 30 plus 45, order does not matter because it's commutative. So put your pencil down. This is how nice it is. Since I have two different angles with two different measures, I'm going to call one of them alpha and one of them beta. And now I have sine of alpha plus beta. So all I'm going to do is literally write this equation down. Sine alpha cosine beta plus cosine alpha sine beta. But wherever I see an alpha, I'm going to put 45 degrees, and wherever I see a beta, I'm going to put 30 degrees. So this would be sine 45 times cosine 30 plus cosine 45 sine 30. And that's the hardest part of the problem, is identifying which identity to use, because now we know how to find sine, cosine, and tangent by SOHCAHTOA. So sine of 45 degrees is opposite over hypotenuse, 1 over root 2. Cosine of 30 degrees is adjacent over hypotenuse. Cosine of 45, adjacent over hypotenuse. Sine of 30, opposite over hypotenuse. And now you and I both know you can't have a radical in the denominator. So if I rationalize, this is going to be root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. Square root of 2 times the square root of 3 is the square root of 2 times 3, or 6. Since the denominators are the same, we add numerators. And we cannot combine the square root of 6 and the square root of 2 because those radicands are different. Those numbers under the radical are different. And so we're finished. So sine of 75 degrees, the exact answer, not the rounded decimal, not something your calculator is going to give you. The exact answer is root 2 plus root 6 over 4. Okay? So let's do it again. All right. Let's say we do, let's do this one. Cosine of 15 degrees. So again, 15 degrees is not one of our special angles. So we need to come up with a way, either by adding two numbers together or subtracting two numbers that we know how to find cosine of, we come up with the number 15. So using our special angles, 30, 60, 90, 45, 45, or the unit circle, think of numbers I could add or subtract to get 15. And there's a couple of answers. So I'm going to do them both. Okay? Actually, I'll just pick one. We'll see. I'll do both. It doesn't matter. Some of you may go, well, you know what? 60 minus 45 is 15. Somebody else might say 45 minus 30 is 15. They're both absolutely correct. So I'm going to rewrite this as cosine 60 minus 45. And in this case, those are two different numbers. Therefore, they are two different values, alpha and beta. And now I'm going to follow the cosine alpha minus beta. So I'm going to write this down first. Cosine alpha times cosine beta plus sine alpha times sine beta. And now we simply substitute in the values for alpha and beta. Alpha we're calling 60, beta we're calling 45. So this would be cosine 60 degrees times cosine 45 plus sine of 60 times sine of 45. And then we all just follow the directions, keeping everything lined up. Cosine of 60 is adjacent over hypotenuse. Cosine of 45 is adjacent over hypotenuse, which of course 1 over root 2 is root 2 over 2. Sine of 60 is opposite over hypotenuse. Sine of 45 is 1 over root 2. And therefore, using elementary school arithmetic, when you multiply fractions, you multiply straight across. And since the denominators are the same, you get square root of 2 plus the square root of 6, or the other way around. Those are unlike terms, but they have a common denominator. So you're finished. Now, I'm going to go ahead and work it out the other way in case instead of using 60 and 45, you chose to use 45 and 30. Now, if I had done this, and you can either watch or you can write it down, I'll go through a little bit quicker. Let's say you had chosen 45 degrees minus 30 degrees. This would be cosine alpha times cosine beta plus sine alpha times sine beta. So cosine of 45 is 1 over root 2, or root 2 over 2. Cosine of 30, root 3 over 2. Sine of 45 is 1 over root 2. Sine of 30 is 1/2. Root 2 times root 3 is root 6. And you may already see what's happening. We get the exact same answer because we know addition is commutative. So order doesn't matter on addition. So you'll notice we got the exact same answer no matter which difference we found. Okay. That's the big idea. How do I make it? How does the book make it? How does the author make it more complicated? I'm using air quotes. Well, instead of giving it to you in degrees, maybe they're going to give it to you in radians. All right, I'm going to keep these handy. I'm going to keep my list handy so I can always refer to them. There's absolutely nothing wrong with that. And let's say I'm just going to choose number 14 here. Find the exact value of tangent 7 pi over 12. Well, when in doubt, work it out. I don't know what 7 pi over 12 is off the top of my head, but I know I can figure it out. I'm going to go ahead and change this to degrees because it might be easier. That's what we did it back in chapter 6.1. If I want to change this to degrees, let's see, 7 pi over 12, to eliminate the pi, it's got to be in the denominator, and the 180 has to be in the numerator. That's one way to do it, because we know pi is 180 degrees, so it's the same as saying 7 times 180 over 12. Now to reduce, I can see that 4 goes into 12 3 times, and 4 goes into 180 45 times. Okay? Oh, I guess I could have kept going. 3 goes into itself once, 3 goes into here 15 times. So I end up with 7 times pi times 15. All right. Well, let's see. What is 7 times 15? 7 times 10 is 70. 7 times 5 is 35. So 70 and 35 is 105. Okay. So this is exactly the same as tangent of 105 degrees. Now remember, our goal is to come up with two numbers which add or subtract to get to 105. So again, looking at the numbers 30 degrees, 60 degrees, 45 degrees, and the unit circle, what two angles add up to 105? Well, that's exactly the same as tangent 60 degrees plus 45 degrees. Now that puzzle's done, the rest is just following a formula, following directions. We didn't worry about where these came from. We're just using them right now. We're just using them. So in this case, alpha, or A, is 60, and beta is 45. So I'm going to simply follow this formula. Tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. Just follow the directions. Follow the directions. Tangent is opposite over adjacent. So on a 60-degree triangle, the opposite over the adjacent would be the square root of 3 over 1. I'm going to be very literal this first time. Tangent of 45 is opposite over adjacent, which is 1 over 1. And I already figured those out. Tangent of 60 is root 3. tangent of 45 is 1. So I believe we are left with root 3 minus 1 over 1 minus root 3. So we're done, but we're not finished. Because in Algebra 1, in Algebra 2, we learned that we cannot have a radical in the denominator because we cannot divide by a number that goes on forever. So we have to rationalize this. Since we have two terms, we need to multiply by the conjugate. So 1 minus root 3, I need to multiply by 1 plus root 3. And we reviewed conjugates the other day. When in doubt, just FOIL everything out. So you go ahead, multiply it out. In the numerator, our first plus our outside plus the inside and the last. Denominator, first, outside, inside, last. Root 3 minus root 3 is gone. So I get a 2 over, the root 3's cancel, negative 2. So I end up with negative 1. So tangent of 105 degrees, which remember they gave us 7 pi over 12, is the same as negative 1. That's it. I apologize for running out of room down here. That's it. So we're just going to follow the directions. All right, so that's similar to how you do these. Let's say, I'm always going to leave these here. When in doubt, draw it out. So let's say I gave it to you the other way around. Okay, I'm trying to think which one I want to do. I'm going to do number 32. Number 32 says, find the exact value of sine pi over 18 cosine 5 pi over 18 plus cosine pi over 18 sine 5 pi over 18. Now remember, our goal is to use these identities today, or just practice using the formulas. So this one says sine cosine plus cosine sine. Sine cosine plus cosine sine. Sine cosine plus cosine sine. So sine alpha cosine beta plus cosine alpha sine beta. So this is exactly the same as this first identity. Sine alpha cosine beta. Cosine this first angle, sine the second angle. So this is exactly the same as having an alpha and an alpha, a beta and a beta. Or if you prefer, an A and a B. Well, that is this first identity. This is sine of alpha plus beta. So this is the same as alpha, which they called pi over 18, plus beta, which looks like the other angle is 5 pi over 18. Well, since we want the exact value, notice I could add these together because the denominators are the same. And that leaves me with 6 pi over 18. Well, that fraction reduces. 6 goes into 18 3 times. And now some of you are nodding, shaking your head, going, oh, yeah. Pi is 180. 180 divided by 3. that's the same as 60 degrees. So again, we just use our regular right triangle, our special triangle, sine of 60, opposite over hypotenuse. And we're done. But you got to show me your identity, just simply using substitution. So part of your homework is you're going to need to find the two angles that you're adding or subtracting. Another part of their homework, they're going to tell you the two different angles to use. Notice those are not the same number. And it's up to you to find which identity it is. And the third one is probably the most important. Now we're going to see how we actually use these calculations. So let me interpret the homework for you. Let me show you how to annotate the homework. I'm going to look at number 34. And 34 has 4 parts. Part A, B, C, and D. Okay, now on 34, they gave us cosine of alpha is square root of 5 over 5. And they told us when this happens. This happens when 0 is less than alpha, which is less than pi over 2. They also tell us, I'm going to leave a little blank right here, sine of beta, so the other angle, beta, is negative 4/5, and they're going to tell us exactly which quadrant it's in. And you and I know, since sine is negative, let's see, all students take classes. All students take classes. Since sine is negative, I'm about to either tell you that that angle beta is in the 3rd quadrant or the 4th quadrant. And according to number 34, they say beta is located between negative pi over 2 and 0. Negative pi over 2. Negative pi over 2 and 0. So what I'm going to do first, before I do anything else, I'm going to take what they gave us and I'm going to draw 2 pictures. I'm going to draw an angle alpha and I'm going to draw an angle beta. Angle alpha is located in the 1st quadrant. So alpha is located in this 1st quadrant. There's alpha. It's between 0 and pi over 2. And I know that cosine, which is adjacent over hypotenuse, is root 5 over 5. So that's actually a 1 and a square root of 5. If I unrationalize that, that's not really a term, but notice it'd be 1 over root 5 over 5. Well, how do I find the other side? If I know the hypotenuse, and I know one of the sides, I'm going to use Pythagorean theorem. A squared plus b squared equals root 5 squared. 1 plus b squared equals 5. B squared equals 4. Square root of 4 is 2. I'm going to do the exact same thing with my angle beta. I'm going to draw a picture of it. Beta is located between negative pi over 2 and 0. So beta is in the 4th quadrant. And they told us that sine is 4/5, negative. Sine is opposite over hypotenuse. So again, I could do Pythagorean theorem, and I could recognize that that's a 3, 4, 5 triangle, or do Pythagorean theorem and find the other side. Now we have all our information. Now, part A. Part A says, calculate sine of alpha plus beta. Now again, I had to interpret what the information they gave us meant. So I chose to draw pictures. Now that I have the two triangles and I know which quadrant they're in, I'm simply going to follow the directions of sine alpha plus beta. It says take sine alpha cosine beta plus cosine alpha sine beta. Now look at the pictures. Okay, sine of alpha. Well, alpha is in the first quadrant. So looking at this triangle, sine would be opposite over hypotenuse. Now I'm going to switch to beta. Beta comes from the other angle because it's a different angle. We drew a picture. Beta's in the fourth quadrant. All students take classes. We want cosine. Cosine is positive in that quadrant. Cosine is adjacent over hypotenuse, 3 over 5. So a lot of you are going to like this because you're just following directions. You're drawing a picture and it's like a puzzle. Now go back to angle alpha. Alpha, we want cosine of alpha. Cosine is adjacent over hypotenuse. They also gave it to us. 1 over root 5. And then flipping back to sine beta. Beta came from this fourth quadrant. Sine is negative in the fourth quadrant. Sine of this angle would be opposite over hypotenuse. Negative 4 over 5. Oh, they also gave it to us. Now do the arithmetic. Multiplying straight across, 3 over 10 plus, minus, because it's a 5 times negative 4, minus 4 root 5 over 25. Did I make a mistake somewhere? Sine alpha, right here. Sine alpha, 2 over root 5. I apologize. I looked at my wrong triangle. So those of you that wrote it down, I caught up to you. I got you. Sine of alpha is opposite over hypotenuse. So that's 2 over root 5. 2 over root 5, but I can't have that. Multiplied by root 5 over root 5, I get 2 root 5 over 5. Okay. Because usually, you guys, the denominators, almost every single time, the denominators should be the same. So that's what gave me a hint that I'd made an arithmetic error. There we go. Now I get 6 times the square root of 5 over 25 minus 4 square root of 5 over 25. Now those are like terms. I get 2 root 5 over 25. There's part A. Part B says cosine alpha plus beta. So I'm going to do it again to redeem myself here. All right? So part B says cosine alpha plus beta. Let's try it again. We already have a picture. Draw the picture once, use the information 4 times. It says find cosine alpha plus beta. Well, this year we are allowing you to use your identities and have them with you. So cosine alpha plus beta. Cosine alpha cosine beta minus sine alpha sine beta. Now it says matter of following the directions. Cosine alpha. Alpha comes from the first quadrant. Cosine is adjacent over hypotenuse. I'll come back and rationalize that. Or do it as you go. Cosine beta. Cosine's positive in the first quadrant. Cosine adjacent over hypotenuse. Now go back to alpha. Sine of alpha, opposite over hypotenuse. Sine beta, opposite over hypotenuse, but hang on a minute, sine is negative in the fourth quadrant. And now again, I'm going to rationalize, so 1 over root 5 is the same as root 5 over 5 times 3/5. Negative times a negative is a positive. Multiply by root 5 over root 5. And I already multiplied the negative times the negative, so I don't have to worry about that. And now we end up with 3 root 5 over 25, 8 root 5 over 25. So those are like terms, so we end up with 11 root 5s over 25. So I think you have the idea, but I'm going to do one more. Okay? Actually, we'll do parts C and D together, so we have the complete example worked out. We still have our drawings for alpha and beta. Let's look at part C. Part C says, because I think you have the idea now. Part C says find sine alpha minus beta. Again, I highly recommend you write out the formula so all you have to do is follow it. Sine alpha times cosine beta minus cosine of alpha sine beta. Or if you prefer, capital A, capital B. Now, I'm going to work it out. You work it out. Let's see if we get the same thing. So I'm going to be a little quiet here while you work it out at the same time I work it out. I could reduce my 10 over 25 by 5. So I reduced by 5 on the outside. And now that I think you have the idea, let's try part D. Part D has one of the tangents. Part D has, let me see, tangent alpha minus beta. So it would be the same idea if it had been alpha plus beta. So let's do this one together. So part D says find tangent alpha minus beta. So of course the first thing I'm going to do is write down what the identity is. This is exactly the same as tangent alpha minus tangent beta, or tan alpha A minus tangent B, 1 plus tangent A times tangent B. And again, it's now an active substitution. Tangent of alpha, opposite over adjacent. Tangent of alpha minus tangent of beta. Tangent in the fourth quadrant is negative. Tangent is opposite over adjacent. Now remember, we already found them. So I have a 1 plus, and I already figured out tangent of alpha, and I already figured out tangent of beta. So tangent of alpha was 2, and tangent of beta was negative 4/3. Now we have a complex fraction. 2 negative times a negative is a positive. Positive times a negative is a negative. Okay, so we have a complex fraction. And we went over this the other day. In my opinion, the easiest way to simplify that complex fraction is to find a common denominator between these 4 small fractions. So we need a common denominator between 1, 3, 3, and 1. And that common denominator would be 3. So multiply the entire fraction by 3. Multiply by 3, multiply by 3, multiply by 3, multiply by 3. Because you've just distributed a 3 over 3. So you've multiplied by the number 1. That reduces, this reduces, and let me know what you... All right, I got negative 2. Hopefully you did as well. All right, so we have the idea. The only thing that might look different is how the problem's set up. So I'm going to do part of number 40, and then while we're working on this type of idea, I'm going to do like one of the ones down 74, 78, something like that. I'm not going to do all 4 parts of number 40. We can always draw those if we need them. So number 40, same idea, it's just set up, it looks a little bit different. On number 40, we are given if cosine of theta equals 1/4. And they tell us that theta is in quadrant 4. Find the exact value of, well, first of all, I'm going to do part A. Find sine theta. Hey. No. First thing I'm going to do is I'm going to draw a picture. Theta's in quadrant 4. So I'm going to come all the way around here to quadrant 4. And here's theta. And we know that cosine is 1/4. So adjacent over hypotenuse is 1/4, so we need to find the other side. So Pythagorean theorem, a squared plus b squared equals the hypotenuse squared. And that gives us 1 plus b squared equals 16. So b equals the square root of 15. Now, of course, we always use the positive value, even though we know it's positive or negative root 15, because this represents length. All right, so we now have all 3 sides of that triangle to refer to. So now when it says find sine of that angle, well, sine is negative in the 4th quadrant, and so we end up with negative root 15 over 4. And you're done. You're done. Now I'm also going to do part B. I'm not going to do all 4 parts because I think you'll get the idea. Part B says, find sine of theta minus pi over 6. Well, please remember you cannot distribute a word. You cannot distribute a word, but we can use our identities. Theta represents an angle. Pi over 6 represents 30 degrees. So if this is alpha and this is beta, or if you prefer A and B, I'm going to write it with A and B this time if it's easier for you. This would be the same as saying sine A cosine B plus cosine A sine B, or alpha and beta. I'm interchanging them. Everywhere I see an A, I'm going to put a theta. Everywhere I see a B, I'm going to put 30 degrees, pi over 6. So this would give me sine theta cosine pi over 6 plus cosine theta sine pi over 6. Hang on. Sine is always the same, so both of these should be minus. Minus, minus. All right, now follow the directions. We know pi over 6 is the same as 30 degrees. We also know on any 30, 60, 90 degree triangle, we know those ratios, so we're ready to go. Sine of alpha. Well, we drew a picture of alpha. We found sine of alpha. Sine of alpha is opposite of root 15 over 4. Cosine of 30 degrees. Now I look at my 30 degree reference. Cosine of 30 degrees, root 3 over 2. Minus, now we're back to cosine of theta again. Cosine of theta, well, they gave it to us. Or we could do it as 1/4. Sine of 30 degrees, 1/2. This will give me opposite of root 45. I'll come back to that in a moment. Square root of 45 is 9 times 5, so I could take out the square root of 9. Since the denominators are the same, I can combine them into one fraction. So we're using the identities. We're using them. So draw pictures and logically deduce them. Last example. I know I'm taking my time, and we want to be as thorough as possible. Last example, I will choose it number 78. Find the exact value of cosine. Now sometimes they use brackets, sometimes they use parentheses. Don't worry about it. Inverse tangent of 5 over 12, and that's probably why they use the bracket, was because they also have parentheses in the problem. Minus inverse sine of negative 3 over 5. So more than likely, you're going to see brackets when they also have parentheses. But don't worry about it. The bracket, parenthesis means the same thing. Well, you guys, it's the same thing we've been doing. Inverse always implies an angle. Inverse always applies an angle. Notice that's a different angle because it says inverse sine. Those are different, so I'm going to call that beta. And now notice what we have. We have cosine alpha plus beta. You know what, before I do that, let's draw a picture of each of these angles. So this is a directly what we just got finished doing in section 7.1, 7.2. Inverse tangent. Well, we know the inverse of tangent is defined between negative pi over 2 and pi over 2. Because this is positive, it has to be here in this first quadrant. So here's my angle alpha in the first quadrant. Since it says tangent, tangent is adjacent, opposite over adjacent. I'm going to do the same thing with angle beta. Sine also happens to be defined between negative 90 and positive 90. So it's in here. Because it's a negative 3/5, it's got to be in this quadrant here. And sine is opposite and hypotenuse. We've done this before. Now by Pythagorean theorem, we can find the other two sides. You know Pythagorean theorem. That's a 4. You know Pythagorean theorem. 144, 25, 512, 13, 17. A squared plus b squared equals the hypotenuse squared. This is 169 equals c squared. So this is 13. Okay. So now we have the pictures. Hard part's over. Now simply follow the identity. This says cosine of alpha, here I'll even color code it, alpha minus beta, alpha minus beta, a minus b. So the first thing I'm going to do is I'm going to write down the identity. Cosine alpha minus beta goes cosine alpha cosine beta plus sine alpha sine beta. And now you have the pictures, so follow along. Cosine alpha, alpha's here, so cosine of that angle is 12 over 13. Cosine beta, here's beta, cosine is positive 4 over 5, because it's in the fourth quadrant for cosine. Plus, now we go back to sine alpha. Sine alpha is first quadrant, everything's positive. Sine beta, in this quadrant, sine is negative. And then now we have elementary school arithmetic. 12 times 4 is 48 over 65. Negative 15 over 65, which leaves us 33 over 65. So there's a lot of ways to represent an angle. They can give us the measurement. They can give us an inverse. They can give us the angle straight out or a picture of the angle. So there you go, you guys. I've tried to give you a lot of examples on how to use the identities. When we do the second part of this lesson, we're going to be establishing the identities. So you need to make sure you have a list of these written down somewhere so that you can refer to them. All right, have a good rest of your day, and I'll see you next time.